Good morning, everybody. I'm hoping that today's notes and tomorrow's notes go pretty quickly. Today we're talking about dilations. Dilations is very, very close to similar figures, which we did earlier in the year. A dilation is simply changing the size of a figure without changing its shape. So that's taking a triangle or any shape and simply making it bigger or smaller in proportion. If you've ever been to an optometrist or somebody to get glasses or have your eyes checked and they've put the liquids in your eyes that make your vision blurry, they've dilated your pupils, which means they put something in your eyes that make your pupils get bigger. So that's an example of where you might have heard dilation if that sounds familiar. Basically, all we're doing is setting up proportions and solving them. So this first problem, I have this shape, x and 5, and on this shape I have 3 and 15. If you notice, this shape is a smaller version of this shape, so this number relates to 3, this number 5 relates to 15, so I would take this shape, and I would call it x over 5, and I want to compare it to see if the number that shows the same portion that x does would be the same, and then I want to see how 5 and 15 relate. From here, all I have to do is cross multiply. So if I cross multiply here, I get 15, and if I cross multiply here, I get 15x. All I want to do is solve for x. So I could think about this over here as 15x is equal to 15. This means multiply by 15, the opposite would be divide by 15. X is equal to 1. So if I plug a 1 in here, 1, 5, 3, and 15, these measurements would relate to make this shape bigger in proportion. If I multiply both these numbers by 3, 1 times 3 is 3, 5 times 3 is 15. From going here to here, we're getting 3 times bigger. This shape would be 3 times larger than this one. Over here we can do the same thing. Shorter side is x, shorter side is 4, longer side is 9, longer side is 18. I'm going to take these two. It doesn't matter if x goes on top or bottom, just make sure that you know that x and 4 should be in the same place, 9 and 18 should be in the same place. I'm going to call this shape x over 9. I'm going to call this shape equal to 4 over 18. I'm going to cross multiply them and get 18x. Sorry, that's 18x is equal to 36. When I divide both sides by 18, I get x is equal to 2. So if I put a 2 here, 2 and 9, if this were to increase in size by doubling it, 2 times 2 would make 4, 9 times 2 makes 18. So this would be the correct measurements, and if I wanted to dilate it and make it larger, I could change it to 4 and 18. Down here, same thing. If you notice, these triangles are in the same position, so I can say that 11 and 66 go together, x and 72 go together. So I'm going to set this up as this triangle is going to be 11 over x is going to be equal to 66 over 72. When I cross multiply this, I'm going to get 66x, I'm going to do this over here. 66x is equal to, I'm going to take out my calculator, 72 times 11 is equal to 792. When I divide that by 66, I get x is equal to 12. So this side is valued at 12. So if I'm going from 11 to 66 and I'm going from 12 to 72, this shape is going to be getting 6 times bigger. We can do the same thing with dilations even if the shapes aren't set up really, really nicely. So that would be something kind of like 4, 5, and 6 here, where they're the same shapes, but they're not sitting nicely next to each other for us to see whether they're exactly the same. So for number 4, the way that I would know which is which is if I make a little right angle mark here, I can make another right angle mark here, and I can see that when I do this, all they've done to make this triangle is, let me see if I have a scrap, I do. So what they've done is, if you imagine this piece of wood is like this triangle, all they've done is this. They've taken it from this shape, and they've moved it like this. That's all they're doing. So I'm going to say that 108 and 9 go together, x and 7 go together. So I'm going to set this portion up as x over 108 is equal to 9 Actually, I'm going to set that as 7 over 9. When I cross multiply, I'm going to get 9x is equal to, and then 7 times 108. It's going to be 756. When I divide both sides by 9, I get x is equal to 84. And that makes sense. If this side is bigger, if 9's bigger than 7, 108 should be bigger than 84. Number 5, same thing. This is the longer side, this is the shorter side, so I can say x is the longer side, 1's the shorter side. Also, with these two shapes, a dilation is making it bigger or smaller. So dilation doesn't always mean bigger. So we can go from a bigger shape to a smaller shape, bigger shape to a smaller shape. Over here, I would set this up as 8 over 80 is equal to, the shorter side was 8, the shorter side is 1, the longer side is x. When I cross multiply, I'm going to get 8x is equal to 80. When I divide by 8, I get x is equal to 10. So this shape is going to be getting 8 times larger. This last one, I can set up the same thing where I have a right angle mark here and a right angle mark here. Here the right angle mark is pointing towards 88. Here it's pointing towards x. So I know that 88 and x should either both be on top or both be on bottom. I'm going to put them both on top. So I'm going to put 88 on top with 72 underneath is going to be equal to x over 9. I'm going to cross multiply and get 72x is equal to 792. When I divide both sides by 72, I get x is equal to 11. All you're doing today is solving for x. You don't have to tell me how many times bigger the shape's getting. This is all you gotta do.